right. Welcome everyone to this talk on building diagram editors with the Eclipse GLSP framework, the graphical language server platform. My name is Philipp Langer. I work with Eclipse Source. I'm the project lead of Eclipse GLSP, and I'm delighted to talk about the evolution of this project towards reaching the 1.0 release later this year. Just in case you are not familiar with GLSP, it is a framework for building diagram editors, such as the ones that you see here, like UML class diagrams, etc., so that you can not only use them in plain web applications, but also integrate them, for instance, in Eclipse Theia, Cloud IDEs, or VS Code, or even the traditional Eclipse Rich Client platform. GLSP follows the idea of the language server protocol that is hugely popular for programming languages, for building programming language support. But of course, GLSP applies that to diagrams and graphical modeling to enable basically the same benefits that LSP does, but for diagram editing development. Those benefits are, for instance, developing diagram clients that can run in a browser, for instance, in VS Code or in a plain web application, whereas the front end is really focused only on rendering the diagram and on user interaction. Whereas the server basically encapsulates all the language smarts about the diagram. So for instance, how to map a certain source model onto a diagram, which operations can be applied, etc. Eclipse GLSP is an open source project hosted by the Eclipse Foundation and basically provides four types of components, such as a server framework that allows you to build domain-specific or diagram-specific servers on top of it, the extensible protocol to communicate to a client that is built on top of a client framework that defines the rendering and stuff, as well as the platform integrations that then allows you to seamlessly integrate that with the platforms I mentioned before, like VS Code or Eclipse Theia. Since diagrams or diagram editors are by nature domain specific or very specific to a certain use case and graphical language, it is, of course, extremely crucial that all of these components are open for customization and easily extensible so that you can really customize everything that is needed, from ranging from rendering through to domain-specific behavior that can then be integrated. The way that the GLSP client and server communicate with each other is as follows. So whenever you open a diagram editor in, for instance, Eclipse Theia, an initialization request will be sent to the server with, for instance, a URI. The server is then responsible to load the respective model source, which holds all the information required for this particular diagram. This model can either be an EMF model, XText, plain database, or even JSON files, whatever you use as your data source. What the server then needs to do is to translate that basically into a so-called graph model, which is a structural JSON-based description of the diagram in terms of typed nodes and edges. This graph model is then sent from the server to the client, which then translates with the help of Eclipse Sprody, also a really cool Eclipse project, you should check it out, onto so-called SVG views, which then basically produce SVG in order to render the diagrams. On top of that, of course, there is tons of generic editing tools like for creating, moving, resizing, deleting elements and edges and so on. Of course, the protocol defines a bunch of different actions. So for instance, to obtain all the available palette items, which operations can be applied, or even, for instance, to resolve navigation targets and stuff like that. So whenever a client then wants to, for instance, create a node, this will result into an action that is sent to the server, which then typically updates the original model source, regenerates the graph model, and sends an update back, action back to the client, which then re-renders the new version of the diagram on the client. So much about the theory. Let's have a look at how this actually feels like in practice. Here, a little demo. We see here an Eclipse Theia online IDE where I've registered a GLSP editor for the WF files. So whenever I click on that, you'll see that a diagram editor opens. Of course, you can do all the usual stuff like zooming, panning, and stuff like that. And the server already told this client which elements I can create. So for instance, I can create now an automated task. I can create, for instance, a decision node and create edges as well. Of course, you can then also change labels and so on. A few of these nodes are resizable. This isn't, but for instance, this one is, that's specified by a diagram configuration on the server. And you have all the usual stuff like undo, redo, and also things like copy paste. So I can, for instance, just copy that over here and do stuff like that. In addition to all the model manipulation that runs on the server also provides validation, of course, which requires modeling know-how. So that runs on the server. As soon as I enable that, the server sends back a couple of issue markers, for instance, to show me all what's wrong with this diagram. And then this is also even populated to the problems view, where I can then click and navigate to the respective tasks. Another nice more recent feature is that it also detects, for instance, intersections and renders them nicely. So for instance, as you can see here, whenever there is an intersection, this is visually highlighted as well. So basically, for all of those features that you've seen here, there is generic support or generic implementations on the client, as well as dedicated protocol actions. And for all of these protocol actions, then you hook up your domain-specific implementation on the server. So this is essentially done in a server module where you bind all these domain-specific implementations, and the client-side stuff is done in the client module, where you specify how the particular node types are rendered onto SVG, as mentioned before. So let's have a brief look at the server module real quick. So basically, it's a simple Java class where you just extend the base class and specify what the ID of the language type is. Then you can specify the diagram configuration, which basically registers all node types and edge types and how they can be connected with each other, which of them can be, for instance, resized or not. Then you specify where the model needs to be loaded from. So that's essentially this arrow here that you implement here, so where to get this original source model from. Um, then how to translate that into a G model, which is the specification of what needs to be rendered. So that's essentially this part here that is then sent to the client. Alongside that, there is, of course, a couple of more things you can do. So for instance, you can register handlers that actually implement the manipulations of the model, or additional action handlers, model validators, context item providers that specify what should show up when you right-click here and stuff like that. On the client module, mostly what you need to do is essentially, sorry, this one, is essentially specify how specific node types are rendered. So for instance, here the activity merge node, which is this one here, is to be rendered with a diagram, a node view. And in the implementation of this diagram node view, you essentially see that this node is then mapped onto directly to SVG, where you can then specify how this is going to be rendered. So all this code is available as open source, so you can look at that as an example in the GLSP repository, and obviously use that for your particular domain-specific or diagram-specific implementations. Right. So since the inception of GLSP in 2018, I think we came a pretty far way. So looking at the, I have to admit, pretty ugly first version of a diagram editor that we've built back then to what we have now, a couple of commercial tools built on it, as well as a few open source tools with a bunch of features that have been added over the time, as well as a bunch of integrations into, for instance, Theia, VS Code, Eclipse, and even EMF Cloud, which, by the way, allows you to combine GLSP with model servers that are shared with, for instance, property views, tree views, and so on, so that they can all work against the same model. You can pretty much with a GLSP build pretty nice diagram editors and integrate them into entire modeling tools and suites. Right now, we are finalizing the 0.9 release, which acts as a release candidate for the 1.0 release, which is then planned later this year. So no particularly new features will be added, but this is used to evaluate the API. And for this talk, we thought what what would be better than in order to celebrate the upcoming 1.0 release, other than embracing and highlighting the ideas of partners that we had the pleasure to work with in the last years, as well as to highlight a few of the contributions that we received over the last particular years and months, and to show them to you. Of course, many of the, especially of the commercial adopters, we can't show those tools directly, and not, especially not the source code. So what we did is we extracted the idea and applied them exemplarily onto our publicly available GLSP examples as an inspiration for your own diagram editors. The first idea that I want to bring to you is basically that I've observed really cool ideas on how to leverage the flexibility and benefit from the flexibility of being able to implement pure SVG and CSS views in your diagram. So of course you can then build basically anything that can be done with SVG and CSS, like here traffic lights, and use them in your diagram. But they are not just eye candy. Essentially, you can, if you make them interactive and combine with modeling language logic on the server, do really cool stuff like support the comprehension and analysis of diagrams and so on. Just a very simple example, for instance, if we consider we want to, let me just close that and reopen it. We want to, sorry, just deleting that. We want to support the user by highlighting, for instance, the paths in order to reach a certain workflow step here. We want to show that with an animation, for instance, highlighting all the edges that lead up to that state. What we need basically to do is, first of all, provide the diagram logic in the sense of determining the path. Obviously, we are doing that on the server, and then use just CSS to show how this path looks like. So in the first step, let's just hook up the server logic for that. Let's add, for instance, a context menu item where we can then start with the highlighting. So I just navigate to the context menu item provider registered for this language, and then we add if the selected elements for this context menu request is exactly one, then we create a custom action, which is highlight path action in this case for the selected element, and create a menu item that will execute this action and is enabled if certain conditions hold or not. As soon as we do that, we immediately get this highlight path context item here. But for instance, it won't be enabled if it's not a relevant item, for instance, just an example. Of course, we didn't specify with that yet what should actually happen when you click that. So therefore, we need to go back to the module and register also an action handler for this highlight path action. So let's see what that does. Basically, it just does the diagram logic behind of it by essentially collecting all the incoming edges recursively, and in the end, apply the CSS class called pulse to it. As soon as we did that, we can go back to the client and essentially just add some CSS magic. So whenever there is a path with the pulse class, we do some animations and add some CSS styling to that. And once this is done, we can basically click on any node here to, for instance, highlight the path as you see here. And I'm not sure if you can see it, but they are also pulsating and all that stuff. Right. Just as an example for animation and SVG CSS support. Another cool, really helpful thing is to add custom controls into your diagram editor. As I mentioned before, they are always very use case specific and diagram specific. So you might want to add uh, basically any arbitrary HTML or React UI on top of your diagram, but still be able to send and receive custom actions with other diagram client components or the diagram server. So this way you can, for instance, add filter capabilities, analysis, controls, and stuff like that pretty easily. One example that you could also do is to show transient diagram views. So basically, when you click on some button in your custom controls, you basically on the fly just change the diagram by filtering elements, show impact, and so on. Maybe you want to use auto layouting to show this subset of filtered elements and switch to read-only mode to indicate that this is just a view. So let's see how this can be implemented pretty easily. So first of all, we need to show the UI extension, the custom control on the server. So you see here alongside the registered views that we've seen before, you can basically load an arbitrary amount of different modules into your diagram. There are a couple of default modules, of course. Then there is this configuration that we've seen up here. And then you can add custom ones in addition to that. And I've prepared here a filter module, which doesn't do more than just implementing a filter UI class and register that as UI extension. These UI extensions, they essentially basically provide just HTML. So here in this initialize contents method, we just create an input of type checkbox and specify if it is clicked, for instance, then we send the filter action to the server. And if it is unchecked, then we send the filter action reset. As soon as we have that, we can already show this UI extension. Let me just enable it. So now we see down here exactly the HTML that we've seen before that the user can now use. Of course, this can be much more complex and even more beautiful than this little example here. So as you remember, once I click on that, a filter action is sent. So again, we can now go back to the server. And similar to the path action handler that we've seen before, I can now register a filter action handler. And this filter action handler, again, can basically just implement whatever is needed in order to apply the filtering. In this case, for instance, if the action type is not reset, so if we really want to filter something, we store the initial state just in the initial state of the diagram, the current state of the diagram, just in a property. Then we apply a filter, which is essentially just removing everything that is not connected to a decision for this example. Then we run the auto layouting. We add a CSS class to the root so that we can, for instance, indicate using a other background color that we are in a filtered state. And then we send this filtered model as an update model action back to the client and also switch the edit mode to read only. With that code alone, basically, we can already do things like now filtering. So as soon as I click here, you see that everything else that is not connected to a decision is removed. We switch to a read-only state, so I can still pan and zoom, but I can't click anymore and change stuff. You also see that the palette went away. And of course, you don't lose the previous editing state that you were in. So when I change that, now filter again and go back, this editing state is still persisted. Right. So that's, I think, always good to keep in mind that you can make the diagram really interactive, add custom controls to your diagrams, and so on. What's also really cool is a contribution that we've received recently from Luca Forstner, who immensely improved the VS Code integration of GLSP by adding a native VS Code native way of registering diagram menus, clipboard support, navigation, and so on, and even an API to customize, for instance, message interceptors and stuff like that. So it's really now feels very native. If you build a VS Code extension based on GLSP, you can essentially hook up all the GLSP logic with native VS Code extension points or VS Code APIs. So just real quick to show you how this looks like, we have here a VS Code where I have the same editor that I've shown before for the workflow files registered as well. So if I open that, you see that let me just maximize that, you see that the same diagram now opens. And we have here now native menu items where you can, for instance, even navigate to other diagram elements inside of the VS Code instance. You can run validations and you then see, for instance, also here that they show up in the problems view as well, and so on. Right. Another cool thing that I think is pretty nice is that you can integrate also external libraries really easily. So for here is an example where in a proprietary commercial high-end FBD editor, they have integrated a library called libavoid, which allows you to have automated routing of edges. So when you see, for instance, here that one edge is too close to another element, it would automatically make room for it. Also, what they did is to integrate that with a table that is basically synchronized with the diagram editor, so you can even drag and drop stuff and edit something down here, and it will update the diagram. So that's pretty nice. The libavoid library that I mentioned before for the automated routing is now by contributor Vladislav now ported into WebAssembly build so that it even can be used inside of the client, and that's soon to be available for GLSP as well. That's really great. We were also super happy to see that GLSP could be used in a commercial project for a very different type of diagram that has very constrained layouts. So as you can see, you can't really move stuff here, but you can still structurally change the diagram and it would then auto layout. That was possible by basically customizing the client-side editing tools, hooking up automated layouting on the server, and that went pretty smooth and well. And I think it is great to see that also these different types of diagrams can be well supported with the GLSP framework. Last but certainly not least, I would like to highlight one ongoing contribution by Giuliano. Basically, this introduces a very nice idea of having zoom-dependent level of detail in your diagrams. So essentially, by specifying level of detail rules on the server, you can specify which elements become visible on which zoom level. And then whenever you reach that zoom level, the server gets notified and can update the diagram. And with that, essentially, you can, the more you zoom in, add more and more details. And I think this really opens up entirely new opportunities. For instance, considering property views, they might not even be necessary anymore for this for such kinds of diagrams, because you can zoom into an element as long until a point where you see all the properties of this element, and then edit them directly. So there is not even a need to go to a different view. Same can also be applied basically for layer diagrams, for instance, UML package diagrams, which contain classes, which contain activities for method implementations. You can basically just zoom into those elements and then switch context along the way, which is, I think, a really nice idea. And we hope that this will be available by the end of 2021 as well in GLSP. Right. That brings me to the conclusion. So that's just a few examples that I wanted to highlight from the recent years about good ideas and very nice and valuable contributions. I also want to take the opportunity to point you to a couple of different talks at EclipseCon later today or tomorrow or on Thursday that are related to Eclipse GLSP. So for instance, there is one about model validation, diffing, and so on. Then GLSP used in the context of building a UML editor, as well as an adopter story of using EMF Cloud and these related technologies for a particular application, modeling application. In summary, I would like to say that over the years, I think what really makes a difference with GLSP is that it is highly extensible and open for customization. And that's, I think, super important for building domain-specific diagram editors. Because for domain-specific things, you need to have full control over any mechanisms, and you need slim abstractions where control matters so that you can really embrace and use the power of SVG and CSS, for instance, for rendering, add your domain-specific controls to it, and so on. Hook up any source models that you may have, whether they are EMF, Xtext, or simply a JSON file. Also, it is great that you can integrate them, those editors, with several different IDE or tool platforms like Theia, VS Code, or Eclipse, which avoids, of course, a lot of lock-in effect with a specific platform. So with that, I would like to invite you to join this innovative community of GLSP and discuss your ideas for next generation diagrams with us. That would be great. A good place to start with that could be the spotlight session or the birds of a feather session at this conference. So please just reach out to us, visit us at our booth at Eclipse Source. And last, I would like to ask you to also evaluate this session. So please let us know what you think about it, ideally with a +1, but still be honest. Thank you very much. Yeah, welcome to the question and answers part of this talk. So thanks for attending. Fortunately, we got quite a number of questions, so I will try to cover as many as possible. So one question was, how would you add new SVG images, like different images for decision nodes that we've seen in the example before? So if you remember, the client part is basically responsible for the rendering, and the server part is responsible for the heavy lifting and loading source models and so on, and map them to sort of like a JSON-based description of how the diagram should look like, which then is sent over to the client, which then again translates that to SVG. So if you want to now add new SVG images or customize the ones that are already shipped with the underlying libraries, what you would do is basically in the mapping from sort of element types like a decision node to the SVG, you register a new SVG view implementation. And basically in this SVG view implementation, you can directly return SVG code using JSX. It's super comfortable. So you have the full power of SVG at your fingertips. Basically, you can add any SVG image there you like. And as soon as you do that, all the decision node types or all the nodes with the decision node type are then rendered with this new SVG view. A similar question in that same direction is also going into the CSS, so not only the SVG part, but the CSS part. The question is there any way to style these as they are web embeddable with CSS? And the question, of course, is yes, you can use, similar to SVG, you can use the full power of CSS, not only to style things, but also even to add animations, which I've shown in this example where we highlight the path. So that was essentially pure CSS. In addition to that, of course, you can control the CSS classes that you apply to certain nodes also on the server. So that means you can enable or disable certain CSS styles from the direction of the server so that you can also bring a real diagram logic and an understanding of the modeling language into that rendering picture and animation approach. Right. Another question was where the graphical position information is stored. Very good question. So that really depends on your particular use case. So if you remember this picture that we have where there is the client on the one hand side and the server on the other hand side, and then it loads the source model, essentially what the source model is, whether it's EMF, JSON, one file or two files, and which formats they have in particular, that's completely up to you. So you can decide where you basically load the different source models from and which contain the semantic part of the model and which contain the graphical part of the model. Very typically, you have one semantic model and another file alongside it, which contains the graphical positions. Right. Another question was about the feasibility of using GLSP to build a block-based coding language. Interesting. You mean, I guess, like Blocky, this graphical language where you can put um, basically different commands in an order and have special nodes for while loops and stuff like that. That's very interesting. So yes, it's feasible to use GLSP for that. However, of course, it requires some customization when it comes to the positioning of those blocks that you put together, because typically those languages have a pretty constrained layout. So they have to snap at a certain position, and you can put them at some positions, but at others it's forbidden. And for that, you would have to add basically customizations. If you remember this one example that I showed you in the slides where you have also this constrained layout use case, I guess it's pretty similar to that. So it's certainly possible. You would have to customize the editing tools a little bit, but other than that, it's possible for sure. Right. I think another question just came in. How reactive stays the UI when it becomes a very large number of diagram elements shown? just to answer real quick. So SVG is pretty fast to be rendered in browsers, but of course you can control the number of SVG elements by taking the zoom level into account. So typically you try to reduce the detail, so the number of elements when you zoom out, and add more details when you zoom in. Also, when you've zoomed in, only part of the diagram will be visible, so you don't need to render everything else that's not visible. So with a little bit of tweaking, it can be very, very efficient for also very large diagrams. Right. And I think with that, my time is up. Thanks again for watching, and make sure to contact us anytime, visit us at our booth or at the Birds of a Feather session later. Thank you.